Hi friends. So in this session we are going to derive the expression for double pendulum in 2 degree of freedom system. So consider the statement which is given. Derive the expression of natural frequency and mode shape for the system of two equal masses suspended by the springs of equal length shown in figure. So they have given one special case that the length of the first one and the second one is same. Along with their length, they are also shown that, also given that the masses are also same. So here you can see L1 is equal to L2 is equal to L and M1 is equal to M2 is equal to M. Now consider the first mass or second mass that given with the displacement of x2, then the displacement of mass M1 is the x1. So x1 and x2 are the linear displacements of these two masses from the equilibrium position. And if we consider the angles, then angle of mass when 1, that is the string 1, is theta 1, and angle of mass 2 with string 2 will be theta 2. Means in this problem we have the angular displacement and the linear displacement. Now to get the relation between the angular and linear displacements, we will have to do some geometry. Now before going to that relations, we'll consider the FBD of this system. Now to consider this FBD, consider the tension in this string 1 as T1 and tension in string 2 as T2. So when I am going to consider this tension T1 and T2, means directly we can draw the equilibrium diagram for the mass 1 and mass 2, that is the FBD. So free body diagram of mass 1 and of mass 2. This free body diagram will provide us the differential equation of vibration. So here on this mass 1 you can see there is one string. So this is the first string, and other side there is another one string. Now the angle of this string with vertical is theta 1. So with vertical this angle is theta 1. Similarly with vertical for second string the angle is theta 2. So this angle with vertical it is theta 2. So here we will consider the forces which are acting on this mass 1. So in the first string the tension T1 will be acting in upward direction, and in string 2 the tension T2 will be acting in downward direction. See, while giving the direction to tension, the tension is always away from the body. So M1 is our body, so this tension for first string away, and if you consider for second it is away. So it is away from the body. Now along with this tension we have the weight of this mass which is acting in downward direction. So the weight of this mass is M1g. Along with this we'll have to give the inertia force. See here the displacement of mass 1 is x1 in the right side. So the inertia force must be acting in the left side, and that is the M1 x1 double dot. Okay, so this is the M1 x1 double dot, which is the inertia force acting on mass 1. So the mass 1 will be having tension T1, tension T2 and inertia force. Similarly we can write for mass 2. See, mass 2 is attached to only the upward string. So here I will show you the string of mass 2. Okay, and this is the force which is acting in that string. Just I will make some, I really so this is the string 2 having the tension T2. Now the angle of T2 with vertical, if you see here it is theta 2. So I will draw here theta 2 with vertical, this angle is theta 2. Now the weight of this mass is acting downward, so I will show it by M2g. So this is the mass which is acting in downward direction. Now if you see the linear displacement of mass, then this linear displacement in right direction, so the inertia force will act in the opposite direction, and that is the m2 x2 double dot. So this is the inertia force. Now to solve this one, we will require some relations between this x1 theta 1 x2 theta 2. So to find out this relation x1 theta 1 x2 theta 2, see, I am going to draw one triangle. Just see here, just see the cursor. So this small triangle I am going to draw here. So this is the geometry that we will require. So this is the triangle 1, where this angle is theta 1, this length is L1, and this linear displacement is x1. Similarly I will draw for this mass 2 also. So consider this string, then this perpendicular and this vertical line. So I will draw this second triangle. In the second triangle, this angle is theta 2, this length is L2, and this linear displacement from this point to this point, this must be x2 minus x1. So it is x2 minus x1. Okay, so by using these two triangles, we will get the relation between x1 and theta 1. So here I will write the relation. So for that, take the sine theta. So sine theta 1 will be equal to opposite x1 divided by hypotenuse L1. So sine theta 1 will be x1 by L1. Similarly, write here sine theta 2. So sine theta 2 will be opposite x2 minus x1 divided by L2. So this is the sine of these angles from these two triangles. But if the angular displacement, that is theta, is small, then sine theta is equal to theta. So here I will write sine theta is equal to, nearly equal to theta. So we will use this mathematical term, that is sine theta is equal to theta. So ultimately this will become theta 1 is equal to x1 by L1 if theta is small. Similarly, I will write here theta 2 will be equal to x2 minus x1 divided by L2. Okay, means from this expression we got the relation of theta 1 and theta 2. Okay, and this we will require during the expression. So I will keep aside. Okay, so you can give the equation number for this one, or you can keep aside, and whenever required we will recall this term. Now we will go to the FBD. See, in FBD the mass mg is vertically downward, the accelerating force is vertically horizontal, but the tension T1 T2 in both cases it is inclined. So we'll have to resolve. So I'm going to resolve this term. So resolve this T1 in horizontal vertical, resolve this T2 into horizontal vertical, resolve this T2 into horizontal component and vertical component. Now what will be this component? See, keep remember that if the angle is given with vertical, then vertical component is cos, and if the angle is given with the horizontal, then the horizontal component will be cos. So here we have the angle with vertical, so I will write T1 cos theta 1. So vertical component will be T1 cos theta 1, and the horizontal component will become T1 sin theta 1. Okay, similarly I will write here also we know the angle with vertical, so it will become T2 cos theta 2. So the horizontal will become T2 sin theta 2. Similarly, we can write for this T2. See, we know the angle with vertical, so this will become T2 cos theta 2, and this will become T2 sin theta 2. Okay, so I have resolved all the forces which are given into the system. Okay, now we have the trigonometry, that is the relation between theta and x. We have these resolved forces. Now to solve, again we'll move to the F building. See, if this system is in equilibrium, then for equilibrium condition we can write, summation fx is equal to 0 and summation fy is equal to 0. Initially I'll take summation of forces in y direction is equal to 0. So consider for first one, consider only forces in y direction. So you can consider any direction positive. If you consider upward positive, then downward negative. If you consider downward positive, then the upward will be negative. So I'll consider downward positive. So this m1g is acting downward, so it is positive, minus, see here the component of t2 cos theta 2, it is downward, so positive. Now t1 cos theta 1 minus, sorry, this t2 is positive, so t1 will be negative cos theta 1. See, we have only mg, t2 and t1. These are the three downward forces. So I have considered the forces in y direction, not a downward, in y direction. Okay, now see here what we have considered, the theta is small. So if theta is small, then sin theta becomes theta, then cos theta becomes cos theta. Suppose theta is small, means almost 0, so cos 0 is nothing but 1. So the cos term becomes 1 when the angle is small. So we can write minus m1g plus t2 into cos theta is 1 minus t1 into cos theta is 1. So we'll get the relation between t1 and t2. So transfer this mg on the other side. So transfer this mg on the other side. So we'll get so it is m1g is equal to t2 minus t1. Okay, so we got t2 minus t1 is equal to m1g. Okay, now similarly we can write for the second one. So here I'll write for second one, summation fy is equal to 0 equal to, here we'll get for y direction what we are going to get, m2g is downward, so consider it is positive, then t2 is upward, so consider this as negative, so minus t2 cos theta 2. But if the theta is small, directly we can write m2g minus t2 will be equal to 0, so t2 will be m2g. Now here you can see they have, in the problem they have given that m1 is equal to m2 is equal to 1, so I'll put t2 is equal to mg. Okay, so we got one relation, that is the t2 is equal to mg. Now we'll quickly recheck this one. See, summation fy is equal to 0, so here m1g is downward, then t2 cos theta is also downward, and the t1 is upward, so this term is negative, t2 is positive, and m1g is also positive. Okay, so I have made one mistake here, actually m1g is positive, so I'll erase this term. So find out the value of t1 from this equation. So transfer this t1 on this side, so t1 will be equal to m1g plus t2, or you can write t1 minus t2 is equal to mg. See, instead of m1g I have written here mg because the masses that they have given in the statement are same. Okay, so we got the relation between t1, t2 and mg. Now this one we have written for vertical forces. Now we'll write for horizontal forces. So I'll start from this one. So summation fx is equal to 0 for first case. So go to mass 1 and consider the horizontal forces only. So here m1 x1 double dot, it is horizontal. So I'll write here, just wait, m1 x1 double dot. I'll consider left side at positive, so the right side becomes negative. So m1 x1 double dot positive here. Then the next force is t1 sin theta 1, so plus t1 sin theta 1. Then the next one, see here in FBD, this one is vertical, this one is vertical, this one is vertical, so only this term is remain. So it is minus t2 sin theta 2. See, while writing this I have considered left side positive. Yes, we can consider right side positive. You can write the equation, you will get the same relation. Okay, so if this angle is small, then theta is equal to, sin theta is equal to theta. So we can replace this one as m1 x1 double dot plus t1 theta 1 minus t2 theta 2 equal to 0. Now put the value of theta 1 and theta 2. Here you can see we have the value of theta 1, we have the value of theta 2. So just put the values. So m1 x1 double dot plus, what is the value of theta 1? It is x1 by L1 minus t2. What is the value of theta 2? x2 minus x1 divided by L2. Okay, so we'll simplify this equation. So m1 x1 double dot plus, I'll write this as t1 by L1 into x1 minus multiply by this t2 inside, so t2 x2 by L2 minus minus will become plus t2 x1 by L2. Now whatever the terms which are common, just take it common. So here in first term and in last term you can see the x1 is common. So I'll write m1 x1 double dot plus, I'll take x1 common, so in bracket it will remain t1 by L1 plus t2 by L2 minus here t2 by L2 into x2. But in the problem statement just check, they have given L1 is equal to L2 is equal to L. So I'll implement. So put L1 is equal to L2. So this equation will become m1 x1 double dot plus x1 in bracket. See, the L1 and L2 is same, so denominator will become L, and in numerator it is t1 plus t2. So denominator is same, minus t2 by L2 into x2. Now just check the values of t1, t2. Just check the values of t1 and t2. So we got the relation that m1 x1 double dot will have to put the value of t1 and t2. So after putting the value we'll get the relation. So we'll have to put the value of t1 and t2. So just check, the t2 is mg and the value of t1 somewhere I have made one mistake, so just wait. Okay, so here I am going to put the value. So while putting this value, just see, I am going to modify this one. We know the value of T2, so T1 will be mg plus T2. T2 is nothing but again mg, so T1 will become 2 mg. Okay, so we'll have to put this value of T1 and T2 here. So I'm going to put, so m1 x1 double dot plus x1 in bracket, the T1 is nothing but 2 mg plus T2 is mg divided by L minus T2 is mg divided by L into x2. So this equation will become m1 x1 double dot plus x1, 2 mg plus mg is 3 mg divided by L minus mg divided by L into x2. So this will be the equation number A, and this equation we got from the relation. Now similarly I am going to repeat for mass 2. Now here I'll write, see, I started this relation from here, we have transferred to here. Now here again I am going to continue from this one for mass 2. So for mass 2, write down the summation fx. So what will be the summation fx? See, m2 x2 double dot plus T2 sin theta 2 will be equal to m2 x2 double dot, just wait, where is the cursor? Yes, here, m2 x2 double dot minus T2 sin theta 2 will be 0 plus T2 sin theta 2 will be equal to 0. So I'll rewrite m2 x2 double dot plus T2 is nothing but mg and sin theta will become theta 2 is equal to 0. So m2 x2 double dot plus mg, what is the value of sin theta 2? Just check here, x2 minus x1 divided by L. So I'll write here x2 minus x1 divided by L. See, instead of L2 I am writing L because the length is given as same. So m2 x2 double dot plus mg by L into x2, then minus mg by L into x1 is equal to 0. So this will be the equation number B. So I have written the two equations, mg by L x1, just see here, m2 x2 double dot mg by L x1 mg by L into x2, and here just see, because of the addition of this T1 and T2, so 2 mg plus mg, it becomes 3 mg by L, okay, and mg x2. Now we have the two differential equations. The first one m1 x1 double dot plus this term, and the second one m2 x2 double dot plus this one. Now the solution of this equation A and B will be, so I'll write here, solution of equation A and B, as both the equations are differential equations. So I'll write x1 will be equal to x1 sin omega t and x2 will be equal to x2 sin omega t. Now quickly what we'll do, we'll differentiate this one because in this equation we have x1 double dot. So differentiate with respect to time. So this will become x1, differentiation of sine is cos omega t, and differentiation of omega t is omega. Similarly I can write here x2 dot will be x2 omega cos omega t. Now differentiate one more time. So x1 double dot will be x1 double dot x1 omega, differentiation of cos is minus sine, and differentiation of omega t is 1 more omega, that is x1 omega square sin omega t. So differentiate here, so minus x2 omega square sine omega t. So this will be the solution. Now we will have to put this solution in equation 1 and in equation 2. So I am going to put in equation 1 and in equation 2. So put in equation 1 and 2. See, for simplicity I am going to put here. So I'll make the half part of this page. Here I'll put in equation 1, here I'll put in equation 2. So here I'm going to write equation 1. It is m1 x1 double dot plus x1 in bracket 3mg by L minus mg by L into x2. So this is the equation 1. And here I'll write in equation 2. Equation 2 is m2 x2 double dot plus mg by L into x2 minus mg by L into x1 is equal to 0. Okay, so I have written both the equations, differential equations, in the half part. So simultaneously we can do, first we will do for the equation 1. So here put the value of x1 and x1 double dot. So this will become 0 is equal to m1, value of x1 is minus x1 omega square sine omega t. Okay, so sine omega t plus put the value of x1 sine omega t 3 mg divided by L minus put the value of x2 sine omega t mg by L. Okay, so I have written the value of x1, x2 and x1 double dot. Now just see, the sine term is common in all. So take sine common and transfer to this side. So when I take sine common and transfer to this side, so this will become 0 divided by sine, that is equal to sine 0. So the right side will become minus m1 x omega square plus x1 into 3 mg divided by L minus x2 into mg divided by L. Now just take the common terms. See here, the x1 is common in first two terms and x2 transferred to that side. So when x2 is transferred to other side, x2 will become positive. Okay, so take x1 common here. So here what will be remained? Minus m1 omega square plus 3 mg divided by L. Okay, now take the ratio. So x1 by x2 equal to, so I have transferred this x2 on this right side. Now transfer this total term on that side. So mg by L, this mg by L is in numerator, divided by denominator is minus m1 omega square. Instead of m1 you can write m, because m1 equal to m2 is equal to m, plus it is 3 mg divided by L. So this will be the equation number C. Simultaneously I'll put the value of x2 double dot, x2, x1 in this equation. So we will get one more equation of x1 and x2. So I'll write here m2. What is the value of x2 is minus x2 omega square sine omega t plus mg by L into, what is the value of x2? x2 sine omega t minus mg by L. What is the value of x1? It is x1 sine omega t is equal to 0. So from this take sine omega t common. So the equation will become minus m2 x2 omega square plus mg by L into x2 minus mg by L into x1 is equal to 0. We have taken sine common and transferred to other side. Now in first two terms just see x2 is common, so the bracket will become m2 x2 plus mg by l. Okay, and this minus term will transfer on the other side, so mg by l divided by x1. Okay, now we'll require the ratio of x1 and x2, so transfer this x2 on other side, so x1 by x2, and transfer mg by l on this side, so m2 x2 plus mg by l divided by mg by l. Here this equation will become equation D. See, I have written here m1 and m2, but m1 m2 are same, so we can directly put m for m1 and m2. Now equate the equation C and D. So equating equation C and D, because on both the equations we have x1 by x2, so this equation will become mg by l divided by minus m omega square plus 3 mg by l. See, here instead of m1 I have written m, because m1 is equal to m2 is equal to m. Similarly, I'll put here, instead of m2 I am going to put m. See, x2 I have taken common here, so here it is omega square. Okay, so I made one mistake here, it is omega square. Okay, so I write m omega square, this term is minus, plus mg by l divided by mg by l. Now we will cross multiply. So cross multiply the terms. So this is mg by l into mg by l. So I have transferred this mg by l here. Now transfer this term on this side. So this will become, this is actually a minus term, minus m omega square plus mg by l into, take this term, minus m omega square plus 3 mg by l. Okay, now we'll multiply. Just multiply this one, so this will become mg by l bracket square. It will be equal to, now multiply by first term, so minus minus will become plus m square omega raised to 4, first term. Now multiply to the second term, so second term will become minus m omega square into 3 mg by l. Now multiply to the second term, plus mg by l into minus m omega square. Now multiply this next term, so mg by l into 3 mg by l. Okay, now we'll simplify this one. Now to simplify this one, just see here, it is m square omega raised to 4 minus. So here you can see m omega square, both the terms are minus. Here we have mg by l, here we have mg by l, means this total term is minus 3 mg by l m omega square, and this term will be minus m omega square mg by l. So minus 3 and minus 1 will become minus 4 mg by l into m omega square. Okay, so the next term will be, the multiplication of this will be 3 m square g square divided by l square, and here we have mg by l bracket square. Now transfer this term on that side, so here it will be 0, m square omega square minus, this term will become 4 m square g by l omega square plus 3m square g square by l square minus m g by l bracket square. So individual term square. So finally we'll get this term as m square omega raised to 4 minus 4mg by l omega square plus this term will become 2 mg by l bracket square. Okay, so solve this equation. By solving this equation we'll get the answer. So we can solve equation by solve quadratic equation. So how to solve this quadratic equation? Omega square will be equal to minus b plus minus root b square minus 4ac divided by 2a. So what will be the value of b? It is 4mg by l. What is the value of a? It is m square. What is the value of c? It is mg by l bracket square. 2mg by l bracket square. Put all this value, we will get the answer of omega, and this answer comes out to be 2g by l. Okay. So this is the derivation.